Last example, simplify by adding like terms. We have 2x squared y, 3yx squared, x squared y squared, x squared y, and x squared y squared. All right, so everything has x and y in it. Can we all agree to that?
Yep.
Yeah.
All right, so we're good with the same letters. Let's look at powers. First off, this is an x squared y power, and this is what I would do on my paper. Obviously, you have a pencil that doesn't have different colors, so I'm going to use one color. I'm going to do some underlining to represent like terms. So I would transfer this out of my book onto my paper just like that, and I start underlining things that are like terms. X to the second, y to the first. X to the second, y to the first. X to the second, y squared, different. X to the second, y to the first, same. X to the second, y squared, different. So these three that are single underlined are like terms.
What if you underline different?
What?
What if you underline the other ones?
Well, I'm going to. So watch how I do the next one. These three are like terms with each other, right? Now this one isn't, right? So that's different. So I'm going to go double underline x squared, y squared, x squared, y squared, double underline. Okay, so that's, if it were my paper and I'm using a pencil and I don't have different colored pencils, I've just got my one color pencil, that's how I'm going to look, my paper's going to look. Single underline for one set of like terms, double underline for another set of like terms, triple underline if there's a third set of like terms, all right? One other thing I would do on my paper, if it were me, and I was just first learning this topic, or I learned it last year a little bit and I'm just reinforcing what I learned from last year, I would put my coefficients of 1 on those two guys right there just to be safe that I don't forget there's 1s in front of those. Alright? Now looking at my single underline objects, I've got a positive 2, I've got a positive 3, and I've got a negative 1. Okay, so if I add the numbers in front, 2 plus 3 makes 5, minus 1 makes 4. What made them the same was x squared y to the first. Again, in whichever order you want. What?
Oh, never mind.
That's for the single underlined ones. All right. Then my double underlined ones, I've got plus 1, and I've got minus 4, right?
So negative 3.
That makes negative 3. Very good. So negative 3, and what made them the same was x squared y squared. That's my double underlined answer. This is not a like term to that. We cannot add or subtract unlike terms, so that's the best I can possibly do. Okay, let me mention a couple things here just to finish this up, just to make sure there's no misunderstanding, because I get people doing wrong stuff all the time, and things just kind of pop in my head occasionally of things that people have done wrong before. Look back at example 1. The powers are 2, 2, 5, and 3. The final powers are 7 and 5. Did the powers change? Yes. What are we doing to the letters here?
Adding.
We're
no.
multiplying letters, which adds powers, right?
Yeah.
Okay. Powers were x squared y, and x squared y. What are they here? X squared y. Did the powers change?
No.
What am I doing to the terms up here? Adding and subtracting terms. Adding and subtracting terms does not change powers. Multiplying letters changes powers. So when you're adding like terms, and this is the task given to you, make sure the powers don't change in your work. All right? Only change the coefficients. 2 plus 3 minus 1 made 4. 1 minus 4 made negative 3. That's what changes the powers that made them the same. X squared, y squared, x squared, y squared, x squared, y squared go on the answer. All right? Do not change powers when you're adding and subtracting like terms. Only change powers when you're multiplying letters together.